Hello everyone. So in this video we will cover factory method design pattern, and this one video will be enough for you to understand everything about it. So let's get started. So first of all we will start with what is factory method pattern, why we use it, how to achieve it. So how to achieve it means what are all the steps you need to write so that you can incorporate this pattern. Then we will see the code implementation of it in C++. And in the end we will discuss the benefits and some disadvantages of this pattern. So factory method pattern is a creational design pattern. There are three categories of design pattern and it is a creational design pattern. It provides an interface for creating objects in superclass but allows subclasses to choose the type of objects that will be created. So this is a very abstract definition, and when we will go into details we will understand what superclass and subclass concept mean here. It follows open close principle. So I think many of you are aware of solid design principles, and one of them O is open close principle. This design pattern follows that. Now why use factory method? Now since it allows object creation through interface, we can modify or expand system without affecting your existing code. So you all are aware, right? Whenever we use interface, you can always create concrete classes and you can add as you need them. So introducing new type of object in future becomes super easy, right? So again, there might be some confusion here that what does it mean by modifying or expanding the system. We will take an example and cover everything. So now how to achieve it? So to understand how to achieve it, we will take an example. Let's say you are running a logistics company and you have two mode of transport available. One is road transport and one is sea transport. So for road transport you have a truck, via truck you transport, and for sea you deliver via ship. Now what you want is, you want to let's say if a client wants to choose a road logistics, they should be able to your system should be able to deliver the parcel via truck, and if they select sea logistics, it should be able to deliver via ship. So what do? We divide our system into two parts. First is the product, second is the creation of that product. So in this case the product is the transport, that we want to create a multiple mode of transport. So for that we will first create a transport interface. So it will have a deliver function which every concrete class or derived class has to implement. So now if we come, let's say we create two concrete classes, one is truck and other is ship. Now truck has to implement the deliver function, and in this the truck will write its appropriate code in which how to deliver it via truck. Similarly, ship will implement the deliver and appropriately so that you can make a delivery by ship. Now the different mode of transport is ready. Now we come to the main class, which is the logistics. So again, logistics will be an interface, and it has in this case two functions. One is create transport and another is plan delivery. So this create transport is the main factory method we are talking about. So this create transport provides a way to create different mode of transport, right? Now, and every concrete class has to implement this create transport and create their appropriate transport. So this is what it means, that subclass will decide which type of object to create, and then it also has a planned delivery. Based on that transport mode of transport, it will plan the delivery. So now we create one class called road logistics, and it also implements a create transport function. And what it does, it creates the transport of type truck. Similarly, sea logistics creates the transport of type ship. So now if a client says, okay, I want a road logistics, so whenever you create a class of road logistics, it already has created the mode of transport as truck, and then you can plan the delivery. So all of this we will see it in the code as well, but this is what the overall layout looks like. So if we see it again, this is the first part. We create the product interface, right? Then we create different products based on the interface. In this case we create different modes of transport. Then we create, this is called as a creator, we create a creator interface which declares the factory method, and all of the different creators or the concrete creator classes will have to implement that factory method and create their respective products. Okay, so now let's look at the code. All right, so now if we see here, let's start with the transport. So this is a transport interface. Say it is in C++, so there is no interface keyword here, but with the virtual, you can define that which function will has to be overridden by its derived classes. So it has only one function right now, which is deliver. Now we create one truck class which override the deliver, and we create one ship class which also override the deliver. Now let's look at the implementation of these functions. So in this we have just as a prototype, we are very simplifying it and saying that all the deliver function for truck, it will just print that it has made the delivery by truck, and ship has made a delivery by ship. There, like all the business logic will live in this function only, that how to make that delivery. Now let's go back. Now let's go to the logistics class. So here logistics is also an interface. As you can see, this is a virtual function, which means all of the derived classes will has to implement this function. It create a transport and it returns a transport, right? And it also has a planned delivery function. Now we create one road logistics class which has to override this transport, create transport function. Similarly, C logistics. Now let's see. So for road logistics, the create transport returns a new truck. So if you remember, create transport was returning the transport. So it is returning a transport of type truck. Similarly, C logistics is returning a transport of type ship. Now in the planned delivery, what we are doing is we just create a transport. It doesn't matter which type of transport is it, because the appropriate class, appropriate mode of transport will be returned. So either transport will be of a truck, if we have called planned delivery for road logistics, and if we have planned delivery for C logistics, it will be ship, and then we just do transport deliver. So this logistics class doesn't care about which transport is returned, it will just call the deliver, because deliver is implemented by all the transport derived classes. So that's the code. Now we see all of this as together. So this is our main class. If you see, we create a new road logistics. If a client wants to ship the its courier by truck or by road, they just create the road logistics, and we just do road logistics planned delivery. So planned delivery, what it will do, it will create the appropriate transport and deliver the courier. Similarly, we will also look at for C logistics and planned delivery for that. So now if I run this, we can see for road logistics, the delivery was made by truck. For C logistics, the delivery was made by ship. So now if you notice, if let's say if my company is expanding and I want to add air logistics, right? So it is so simple. Without modifying any existing code, we can create first of all, we have to create a new transport type. So I can quickly create it even. So let's say airplane, right? You made a delivery by airplane, and in the transport CC for airplane, you can simply do it and deliver by plane, right? So there we have not modified any existing code. We have just created a new mode of transport, which is airplane. Now in the logistics, we have to create a new type of logistic, which is, we can say, air logistics. Now again, create transport, nothing, no difference. For the air transport, for the air logistics, we just do create transport and we return new airplane. That's it. So without modifying any existing code, we are able to add a new mode of transport, which is air. Now let's try to do the same thing. Let's try to make a delivery by air. So now we do air logistics and we do planned delivery. It's that simple. Now if we build it again, Yep. So air logistics. So now if we run this, perfect. So as you can see, a new logistics type has been added and it is delivering by plane. So it is that simple. So just by adding this factory method called create transport, we are able to expand our system like this, right? So now we can come back. Yes. So with that, we have seen the code implementation. You can go back in the video to, if you want to, pause at any certain point and want to see the code in detail. So now let's come to the final part of the video, which is the benefits of this. So the first benefit is client code has no control on object creation, which improves your flexibility. As you can see in the main file, that we can treat it as a client code, and there we have not defined which object to create, how to transport. It just says, okay, if you want a air logistics, you create air logistics and then you just plan delivery. It will appropriately deliver it by a plane. New products can be added easily, right? As we have just expanded our code in 2 minutes, we have introduced a new type of delivery, which is air delivery. And so this pattern is useful when you don't know all the product types beforehand, right? If you see, I mean, the in today's world, all the products are evolving, right? We never know that these are all the classes, these are all the product types we are going to offer to our customers. So it is always good to have a factory method which can create on demand any different type of products for you. It also enables user of a framework to add new components. Now let's say your product is a framework or a library which gives user the ability to create any new components in that. So again, if you implement it in a factory method way, your users will be able to add or delete any component in your system. So these are all the benefits. They are self-evident, right? As we have seen in the example. And in the end, there are like a few disadvantages. First is it increases code complexity. Definitely we have to create a interface. We have to create factory method rather than directly, creating an appropriate truck or ship and do the delivery directly. But all of this complexity is very much worth it, as we have seen before. And we might have a slight performance impact due to polymorphism. If you have seen, if we go back, we can see that when we are planning delivery in this function, when we do deliver, we don't know which type of delivery it is. It can be either truck, ship, or airplane. It depends on the type of object transport has. So it is called as a runtime polymorphism. So it might add a very small latency, but in today's world, in such high powerful systems, it should not have any major impact. So that's it. That's everything about factory method design pattern. I hope you like this video. I hope you understood what it is, what are its use cases. And if there is any doubt, if you have any feedback, any comment, please leave down in the comments below. And I will see you in the next video with a new design pattern. So that's it for this. Bye.